ENCLAPSലേക്കുള്ള വഴി ഇനി തനിയെ തുറക്കാം. Subscribe to the Enclaps channel. Ring the bell button and open success. It's that easy.
Hi. Today we are going to discuss about the D block elements in the periodic table. Do you see the D block elements in the periodic table? Today we are going to discuss about the important properties regarding the D block elements. Are you ready? Okay. When you write the subshell electronic configuration and the last electron enters to the penultimate D subshell, then we can say that the element belongs to D block in the periodic table. The elements from the group 3 to group 12 is generally known as D block elements. It starts from the fourth period in the periodic table. They are also known as transition elements. Okay. So, compared to the S block elements, the D block elements also shows metallic nature. Now, if you consider the D block elements in the group as well as period, then it shows similarities in their properties. And also the D block elements shows different oxidation state. If you consider the ions and compounds of the D block elements, they are usually colored. And these ions and compounds of the D block elements are generally used as catalysts in different chemical reactions. Okay. So, now we are going to discuss how to determine the group number of a D block element. Okay. The group number of a D block element is sum of the electrons in the outermost S subshell and the preceding D subshell. That is S plus D gives the group number of a D block element. Okay. Now, let us consider one example. Look at this subshell electronic configuration: 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6. Now, I am going to find out the group number of this element. So, before find out the group number, we just want to confirm the block in which this element belongs to. Okay. So, if you look at the subshell electronic configuration, you can see that the last electron enters to the penultimate D subshell, right? That means this element belongs to D block in the periodic table. Now, we can find out the group number. How will you find out the group number of a D block element? Yes, we just want to count the total number of electrons present in the outermost S subshell and the preceding D subshell, that is S plus D. Here the outermost S subshell contains 2 electrons and the preceding D subshell contains 6 electrons. Therefore, group number equal to S plus D, that is equal to 2 plus 6 equal to 8. Therefore, we can say that this element belongs to 8th group in the periodic table. This is how we find out the group number of a D block element. Okay. Now, we are going to explain why the D block elements show similarities in properties in both groups as well as period. Okay. So, if you write the subshell electronic configuration of a D block element, you can see that the last electron enters to the penultimate D subshell, right? Therefore, the number of electrons in the outermost S subshell remains constant. For most of the elements, their properties are usually determined by the number of electrons in the outermost shell. Okay. So, here if you consider the case of the D block elements, you can see that the number of electrons in the outermost subshell remains constant. That is the reason why the D block elements shows similarities in groups as well as period. We can explain it with the help of an example. Look at this table. Here you can see the subshell electronic configuration of different D block elements like scandium, titanium, vanadium, which belongs to different groups in the periodic table. Okay. So, if you look at the subshell electronic configuration of all these elements, you can see that the number of electrons in the outermost S subshell is 2. That means, even though it belongs to different groups, the number of electrons present in the outermost S subshell remains constant. That is the reason why the D block elements show similarities in properties in both group as well as period. Okay. Now, we are going to explain why the D block elements shows different oxidation state. We can explain it with the help of an example. Okay. When I consider the case of iron, it forms 2 compounds. One is ferrous chloride, that is FeCl2, and another one is ferric chloride or FeCl3. If I consider the case of ferrous chloride, that is FeCl2, the ion is present in +2 oxidation state. Okay. But when I consider the case of FeCl3, ion is present in +3 oxidation state. That is, when it forms the compound, it releases 3 electrons. That is, here if you consider these 2 compounds, in one compound ion is present in +2 oxidation state and another compound ion is present in +3 oxidation state. Okay. So, when I write the subshell electronic configuration of this Fe, Fe2 plus and Fe3 plus, how can you write it? Just look at this table. First, I am going to write the subshell electronic configuration of ion. The atomic number of ion is 26. So, how can we write the subshell electronic configuration? Yes, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6. Now, I am going to write the subshell electronic configuration of Fe2 plus. Fe2 plus means 2 electron released from Fe. So, from where we have to remove this 2 electron? Yes, from the outermost 4s subshell we have to remove this 2 electron. Then how can we write the subshell electronic configuration of Fe2 plus? 1s2, 2s2, 2p6, 3s2, 3p6, 3d6. Now I am going to write the subshell electronic configuration of Fe3 plus. Fe3 plus means 3 electron has to be removed from Fe. So, from where we have to remove this 3 electron? 2 electrons removed from the outermost 4s subshell and the remaining 1 electron is removed from the preceding 3d subshell. Therefore, the subshell electronic configuration of Fe3 plus can be written as 1s2, 2s2, 2p6, 3s2, 3p6, 3d5. Okay. So, if you look at these cases, we can see that iron exists in 2 different oxidation states, right? Fe2 plus and Fe3 plus. So, why these d block elements exist in different oxidation states? It is because when we consider about the outermost S subshell and the preceding D subshell, there is only a small energy difference between these two outermost S subshell and the preceding D subshell. As a result, when it undergoes chemical reaction, along with the outermost S subshell, the preceding D subshell also undergo chemical reaction under suitable condition. That is the reason why the D block elements exist in different oxidation state. Okay. Now, when we explain the properties of the D block elements, we said that the ions and compounds of the D block elements are generally colored, right? So, can we show some examples for this? Here, the first element is copper sulfate. It is blue in color. The second compound is cobalt nitrate. It is light pink in color. The next one is potassium permanganate. It is dark purple in color. The next one is ferrous sulfate. It is light green in color. And finally, cupric chloride, which is bluish green in color. So, here all the compounds of these D block elements are colored, right? And because of this coloring property, D block elements are generally used for oil painting and glass painting. Okay. So, these are some of the important properties regarding the D block element. We will discuss about the F block element in our coming classes.
3 ലക്ഷത്തിലേറെ വരുന്ന ചോദ്യോത്തരങ്ങൾ ഏറ്റവും കുറഞ്ഞ ചിലവിൽ സ്വന്തമാക്കുവാൻ ഉടൻ തന്നെ ഡൗൺലോഡ് ചെയ്യൂ Enclaps, the learning app.